I wanted to work through an example that involves velocity transformations from one reference frame to another reference frame. In this particular example, I'm going to work with everyday velocities that are far from the speed of light. And so we're going to use Galilean transformations, Galilean velocity transformations to transform the velocities from one frame to another frame. So in this particular problem, we're asked to imagine a pedestrian reference frame and a truck reference frame. And the truck reference frame is moving with respect to the pedestrian reference frame. It's moving towards the right at 10 meters per second. Equivalently, the pedestrian reference frame is moving with respect to the truck reference frame. It's moving to the left at 10 meters per second. A passenger in the truck and the pedestrian on the pavement watch a bird flying. And we're told the speed that the bird flies at from the frame of reference of the pedestrian. We're told that the bird is actually observed to fly at 11 meters per second to the right, 9 meters per second to the right, and then finally 10 meters per second to the left. So those are the speeds of the bird from the pedestrian reference frame. We're asked to calculate the speeds of the bird, the corresponding speeds of the bird in the truck reference frame and the passenger's reference frame. Before I start the problem, let me just annotate this sketch with the various reference frames that are involved and the various velocities that are involved. So we're going to be thinking about two reference frames. One of them is the pedestrian reference frame. And I'm going to sketch that here. I'm going to call this the unprimed reference frame. I'm going to label the space coordinate x and the time coordinate t. The second reference frame, as the truck reference frame, I'm going to sketch that over here. Again, I'm just sketching one spatial coordinate and the time coordinate. And I'm going to call this the prime reference frame. I'm going to label the spatial coordinate x prime and the time coordinate t prime. Now, if we're in the pedestrian reference frame, we will see the truck moving and the truck frame moving towards the right at a velocity of 10 meters per second. So plus 10 meters per second. So that's the relative motion of the two frames. And then finally, we're told that the pedestrian in the pedestrian reference frame sees the bird flying at 9 meters per second towards the right, 11 meters per second towards the right, and finally, minus 10 meters per second towards the left. So I'm going to denote those velocities by Vx without the prime, because these are velocities as measured by the pedestrian in the unprimed reference frame. And these are 11, 9, and minus 10 meters per second, respectively. And what we're interested in is the corresponding velocities in the truck reference frame. I'll call those Vx prime. And so this is our job, to calculate the three corresponding velocities in the truck reference frame. So let's just walk through them one by one. So let's just walk through this calculation one velocity at a time. According to Galilean velocity transforms, the velocity of the bird in the truck reference frame is the velocity of the bird in the unprimed pedestrian reference frame, less the velocity of the truck reference frame in the pedestrian reference frame, and we call that VR, the relative velocity. And so if we're thinking about the initial velocity of the bird, that was 11 meters per second. I plug in the 11 meters per second of the bird in the pedestrian reference frame. I subtract off the motion of the truck reference frame in the pedestrian reference frame. And I calculate a velocity of the bird of 1 meters per second in the truck reference frame. If I do the same calculation for the 9 meters per second in the pedestrian reference frame, so the velocity of the bird in the truck reference frame, Vx prime, will be the velocity of the bird in the pedestrian reference frame, less the velocity of the truck reference frame with respect to the pedestrian reference frame. And now I fill in the numbers again. So this time the bird's flying slower towards the right, 9 meters per second in the pedestrian reference frame. I'm going to subtract off the motion of the truck with respect to the pedestrian. And now I get minus 1 meters per second for the bird's velocity in the truck reference frame. And then finally, let's do the calculation when the bird is flying in the opposite direction towards the left at 10 meters per second in the pedestrian reference frame. Its velocity in the truck reference frame will be the velocity of the bird in the pedestrian reference frame less the velocity of the truck reference frame in the pedestrian reference frame, that's VR. And now I'm going to fill in minus 10 meters per second for the bird. I'm going to subtract off the motion of the truck reference frame in the pedestrian reference frame. I'm going to get minus 20 meters per second for the bird's velocity. So these are our 3 results. And let's see if we can make some sense of these results or make some comments on these results. So in the pedestrian reference frame, when I see the bird flying at 11 meters per second towards the right, I see it flying slightly faster than the truck is moving towards the right. It's moving towards the right at 10 meters per second. And so it shouldn't be surprising that if the bird is flying towards the right at 11 meters per second from the pedestrian's perspective, truck is moving towards the right at 10 meters per second from the pedestrian's perspective. The truck passenger sees the bird flying ahead of the truck at 1 meters per second. So that makes some sense. Now, what about when the bird is flying at 9 meters per second towards the right? The truck is moving at 10 meters per second towards the right. So now the truck is going faster than the bird rather than the bird faster than the truck. So the truck is catching up with the bird. The truck passenger sees the bird flying towards the truck at 1 meters per second. It's going towards the left from the truck passenger perspective at minus 1 meter per second. And then finally, if the bird itself is flying towards the left at 10 meters per second in the pedestrian reference frame, and the truck is traveling towards the right at 10 meters per second in the pedestrian reference frame, the truck and the bird are approaching each other at 20 meters per second. They're heading towards each other, one to the left, one towards the right. And so it's not surprising that we see a bird, if we're the truck passenger, approaching us at 20 meters per second. So all these results are common sense results, everyday velocity results for the motion of the bird in 2 different reference frames.